Hey, this is Dave with High Yield Medical Student Stats going over a 2x2 chi-square test on SPSS. A chi-square test is used to compare whether there is a difference in the frequency of a categorical dependent variable between groups or categorical independent variables. There's no restriction to the number of categories in each variable, but to start off today, we will look at an independent variable with two groups and whether the frequency of a dichotomous categorical variable will be different between these groups. In our example, we will be using a chi-square test to compare the frequency of hypertension in patients with or without diabetes. So here is our data sheet in SPSS with the patient number on the left, and then for each patient, whether they do or do not have diabetes or hypertension, with 0 being defined as not having that disease and 1 indicating the presence of that disease. So for example, patient 1 does not have diabetes but does have hypertension. So first, you want to go to the variable view and make sure both your variables are defined as nominal in the measures column. Then you can go to the values and define these different groups. So for our diabetic patients, we have 0 denoting no diabetes and 1 indicating diabetes. Then once we have our variables set up, we go up to analyze, then to descriptive statistics, and finally to crosstabs. Then we put our dependent variable in the row and the independent variable in the column. So for example, we are comparing whether the presence of diabetes affects the frequency of hypertension. Next, we go to statistics and click the chi-square option. Then we go to cells, and we like to have the observed and expected counts checked off, as well as percentages for our rows, columns, and total. We don't change the format or style tabs, but we will go through what that looks like for consistency's sake. In our example, we are not bootstrapping, so we will not click the Bootstrap tab. Finally, click the Display Clustered Bar Charts box, and we can press OK. So here is what the output of our test looks like. The first table displays how many total cases we have, 40, and how many of these are valid or have missing variables, meaning they could not be included in our analysis. We have 40 valid cases for our test. Table 2 shows the breakdown of the groups in a 2x2 table with the total frequency of the dependent variables or columns at the bottom. First, we'll go to the very bottom and see that for all of our patients, 17 did not have hypertension and 23 did have hypertension. Then at the very bottom, we see the percentile of the total patients with or without hypertension, which in our case is 42.5% of patients without hypertension and 57.5% of patients with hypertension. Above that, we see the breakdown in patients with diabetes or without diabetes. It is a 2x2 table with the count representing the number of patients in each crosstab. So in our group of 20 patients without diabetes, which would be under the no diabetes row, under the count row, and then the total, we see that 13 of these non-diabetic patients do not have hypertension and 7 do have hypertension. Then the percent within diabetes row signifies the percentage of non-diabetics without hypertension, which is 65%, and the percentage of non-diabetics with hypertension, which is 35%. In the next row, we see the percentage of patients in that column, so patients without hypertension who are also not diabetic. In our case, this is 76% of patients without hypertension also do not have diabetes. Additionally, we have what is the expected count in each group. Essentially, this is what the frequency of patients would be if the null hypothesis is true, or if the frequency of hypertension would be the same in patients with or without diabetes. The chi-square test analyzes whether the frequency of the columns is different between these rows or groups. So again, for our example, this would be whether there's a difference in the frequency of hypertension in patients with or without diabetes. So all in all, 35% of non-diabetic patients have hypertension compared to 80% of diabetic patients having hypertension. Next, we have our chi-square test output. All of these are different ways to analyze this data, but for our example, a Pearson chi-square test is used. As the p-value is 0.004, which is less than the regular p-value threshold of 0.05, there is a difference in the frequency of hypertension between patients with or without diabetes. Finally, we can display a graph showing the frequency of hypertension in patients without diabetes on the left versus patients with diabetes on the right. So that is our video on a 2x2 chi-square test. We'll be putting out a video showing how to look at chi-square tests with more than 2 groups soon. Let us know any questions or suggestions you have below in the comments. Thank you.